Hello everyone, and welcome again to the second video in this series of electronics tutorials. And this tutorial will explore the light-emitting diode, or LED. An LED is a transducer which converts electrical energy into light. LEDs emit light when current flows through them. You'll find LEDs in almost every electrical device nowadays. When building circuits, they can be used to provide an indication that an electrical signal is reaching a point within a circuit. We'll firstly add an LED to the test circuit we built in the last tutorial. First we need to pause the simulation, then hit the rewind icon. We then double click the connection after the resistor and click the cut icon. This removes the connection. We can now scroll along the component list to find the symbol for the LED. All the components available in every circuit are the schematic symbol you'll find in electronic schematic diagrams, so using this software will help you recognise these symbols. So with the LED in place, we simply connect up the circuit. Before we run the simulation, it's important to know that an LED requires a current limiting resistor of the correct value. If this is not used, the LED will burn out. Burned out components have to be replaced, and replacement components will cost you money. When too much current flows through the LED on every circuit, a flame is shown on the component to indicate this, so if you do see this, you know something's wrong. So we'll increase the value of the resistor to show the LED lighting up properly. And with the 100 ohm resistor in place, the LED lights up. So let's look at some diagrams of LEDs and see how we calculate the formula to see which the correct resistor to use. In this picture we can see a side view diagram of a typical LED. The LED has a lens made of resin and two terminals which are used to connect into a circuit board. The longest terminal is connected to the positive side of the power supply. It is called the anode. The shorter terminal is connected to the negative side of the power supply. This is called the cathode. Another method to identify the positive and negative terminals is to find the flat spot on the base of the LED lens. Inside the lens, the terminals are shaped. These are known as the post and anvil. If we examine the diagram of the bottom of an LED, we can again identify the flat spot and know which is the positive and negative terminal. It is vital that the LED is wired correctly in a circuit to avoid damaging the component. Let's now look at how the resistor value is calculated using Ohm's law. When choosing an LED, the manufacturer will give specific ratings. To calculate the correct resistor, we need to know the forward voltage supply and the forward current. I've chosen an LED with a forward voltage of 3.5 volts and a forward current of 20 milliamps. The next thing we need to know is the voltage supply. In this example, we will use a 9 volt power supply. The resistor is calculated as follows. Firstly, we take the value of the power supply and subtract the diode's forward voltage value. So it's 9 volts minus 3.5 volts gives us 6.5 volts. We then need to convert the diode's forward current value from milliamps to amps. To do this, we divide 20 milliamps by 1000. This gives us the value of 0.02 amps. With these values, we can now use Ohm's law once again to calculate the resistor required. We know the voltage is 6.5 volts and the current is 0.02 amps. So we divide 6.5 by 0.02 to give us 325 ohms. The full equation looks like this. Voltage supply minus the diode forward voltage divided by the diode's forward current. So let's now make the adjustments in the simulator. We need to set the power supply to 9 volts. And we need to set the resistor value to 325 ohms. We then need to set the correct values for the LED we chose. We highlight the LED and click the spanner to adjust. We set the forward voltage to 3.5 volts. The forward current value is already set at 20 milliamps. We now run the simulation and see the LED lighting correctly. Notice every circuit once again calculates all the values for volts, amps and ohms. Let's now add 2 more components to the circuit. We shall add a capacitor and a switch. We'll set the value of the capacitor to 1 farad. In this example, we'll look at how the capacitor works by acting as storage for charge on the circuit. Think of a capacitor like a battery, but the charge inside the capacitor will drain quickly. With the circuit set up, we run the simulation, and before the LED will light up, we need to set the switch to the on position. The LED lights up, but notice that the capacitor is also charged up. But now watch what happens when we set the switch to the off position. The LED stays lit and the capacitor is discharging its power through it. Gradually, the LED dims as the capacitor drains. So let's now remove these extra components and see how we can adjust the power input to make the LED flash on and off. To do this, we click the power supply. And we click the adjust icon and select waveform input. We need to set the high voltage output to 9 volts. And now when we run the simulation, the LED flashes on and off. To change the colour of the LED, we click on the LED component and select the wavelength. The adjustment wheel provides the full spectrum of colours available for LEDs. The wavelength shows the abbreviation NM, which stands for nanometers. In the next videos, we'll cover more on resistors and capacitors. I hope you enjoyed this video. Please feel free to ask questions and leave comments. All the best.